Harris, please adjust your video. Good. Are you guys happy with your grades?
Yes, sir.
Yeah, you guys did a good job. Most of you. I really appreciate. Good. Just keep it up, guys. Nice job. Let me just have my, let me open my notes. Just wait.
Did the files I sent you work? Was that fine?
You wait.
Margie.
Wait. What is the problem?
I was just wondering if the files I sent came as one, like you said.
Don't do this thing. Don't give me hard time, please. You submitted more than 10, 12 files. It's not possible for me to go through just one and one page again and again. 3 pages, they were just on the same pages you submitted.
I've
Why
never
hard time? I don't understand this thing. And then after I send multiple emails to you and you send all again the same pages to me, I requested you just send just one file to me. I don't know why. I really don't know what's going on. Will you please contact somebody in our section so that he or she can help you out?
I think I got them all as one
Let me
file.
finish, please. Oh my gosh, it's too much.
I got them all as one file and I sent them to you.
Not in my email, on Canvas. Because if you send it to, I don't mind, but if you send to my...
I meant your email, like your...
Let me finish. Oh my gosh. Okay, go ahead. You first finish, then after I will speak. Go ahead.
Yeah, I sent them both to your main email because you told me to email them to you. But I also uploaded them on
till late evening, you did not submit any of your files correctly on the Canvas. That's why I say they send it to me, to my email. And again, you did the same wrong thing that you submitted all 10 files to my email.
So they were all together when I submitted them to you. It was all one PDF.
Okay, I will check that thing. But I will not allow you to do the same thing in future. See, you cannot expect to reply, expect from me to reply all your 10, 15 emails in 3-4 hours. Because 35 students, and if all are doing the same thing with 10, 15 emails, it's not possible, right? You can understand this thing. Nobody can reply all 15 emails at a time. It's time consuming. Yeah, so please learn. Okay.
Hello, sir. I'm here. Yes. I got disconnected.
Okay, good. Gage Levine, Solomon Hayes. Green Hart, Paul Mustein, Rodriguez. Rodriguez, did you submit your homework yesterday?
Yes, sir. It was on the same assignment as a test.
Are you sure?
Yes, sir. You graded it.
I graded that. Okay, okay, then it's fine. Yeah. Then Nathan Light.
Yes.
Okay, who is left out? Let me see. Ilyas.
Yes, sir.
Right, Tyson. Okay. Ismail Taylor. Yes, he is here. And Campbell. And Will Hostetler. Let's do one thing, guys. If you want, I can open the Canvas, because Canvas yesterday it was closed at noon, and then after, because two guys, they were facing some problem. So I opened for them the Canvas till 9:30 p.m. Even though they could not, let me put like this, they could not submit their files. If you want, you can take the help from somebody who had not submitted your files yesterday. If you want, you can take the help from somebody. Yeah, all guys are really very good. Anybody can help you out, but you need to take the initiative. You need to ask to somebody. Nobody will come to you and ask you that, do you need my help? You have to ask to somebody if you are not getting any of the things. So if you want, after this class, I can give you 5-10 minutes. I can keep my Zoom video open so that you can discuss in between and try to submit. Those who don't know how to submit on Canvas, they can take the help from the others. Not right now, after the class. And another thing is, the main purpose is, see, I can allow you to submit on my email, but you know, in my email, I can't put any comments if I want to. And you will not come to know what you did wrong. So that's the reason I just want you to submit your files on Canvas. Right, guys? Good. And be careful next time, please. I just want your 2 files, not more than 2. One is for your homework, one is for your test. That's it. And that's what almost all of you guys have done. I appreciate. Thank you so much. Yeah, it's easier for me and easier for you too. And another thing I found is, please, before you submit your file, please make sure that you have to arrange all your pages in a sequence. Again, I will not disclose the name. He knows this thing, but one guy, it was really hard for me to figure it out. He did one example on 2nd page, and then after immediately next example started on 3rd page. I cut the points. Again, I went through 3rd page and I went through 4th page. And I came to know that 4th page is the continuation of the 2nd page. And again, I changed the grade. So, you know, guys, it's hard time for me, for you guys too. And I may make some mistake. After all, I am also a human being. So please just to avoid the mistakes from my side. I don't blame any one of you. But just to avoid these type of things, please try to arrange your pages in a sequence. It would be easier for me to grade your examples correctly. So many places I gave you some extra points. I have not mentioned that thing. Yeah, I gave you some extra points. If you want to look at the comments on Canvas, whenever you can see the balloon sign, just click that balloon. And on the right side, you will find the comments. If something is wrong, why it is wrong. If it is wrong, I just put the cross that this part is wrong. Some people, again, I will not disclose the name. Yes, I don't want to. But couple guys, I asked the integration. You were looking for the integration. You took the derivative. Couple guys. So still you are getting confused between derivative and integration, guys. Please do this thing. Please, please, please. I know you know the material, but because of some silly mistakes, you are losing your points. If you are taking the integration and if you are writing the derivative, if I wish or not, that's the different issue, but I have to cut some points, right? Because that thing is wrong. Am I right, guys? This is just the first exam. Still you have time to improve, so don't worry about it. Those who are, couple guys, they are below, no, 3 guys, sorry. 2 guys, they are getting 65%, 26 out of 40. And 1 guy, he got little less. If they want to talk to me, I don't mind. We can talk about your exam. Maybe after this one, I can set up another Zoom meeting with you guys. Or we can do something like that. But if you want to improve, This is just first time. I'm not going to give you this opportunity in the next exams. So please be careful, because I want all you guys on the same page. I just want to see good grades on your first exam. So if you want to go for retake or like this, we can find some way out. Those who got less than 70, less than 28 out of 40. So please make sure, guys, okay? Just think about it. Those who, you have your grades with you. And if you think that, yeah, you are ready for your retake in next couple of days or like this, maybe on Friday, okay, I can give you one extra opportunity. Online teaching is, for me, I would say it's actually double work, yeah, than the classroom teaching. It's almost double work, yeah. Because in classroom, you know, we can talk face to face. I can have one in my office hours and all you guys can come at the same time and we can discuss lots of things. Here, I have to write it down. If somebody sends the email to me, I have to reply like this. So it's very time consuming. Always I keep my eyes open. Yeah, always. I check my email more than 8 to 10 times a day. More than 8 to 10, every after 1 or 2 hours. I just try to check my email so that I can get back to you very immediately without, before you miss something. Yeah, I'm trying my best, guys. I'm trying my best. And I don't know, I didn't face this problem in spring semester, because I think the rest of the spring semester after 21st of March, because before that I were aware of my students. We communicated a lot with my students, so that was really good sign. So that was not that hard, but right now I think it is a little bit harder than that part, because so many of you are new for me and I'm also new for you. So I can understand that thing too, that it requires some time to develop one rapport. So I can understand that thing. That's fine. I don't mind to work for you. I don't mind. But only thing is, please try to understand our situation too, teaching community situation too. It's not only me, but as far as possible, try to cooperate your professor. Please, if you are taking some other courses with some other guys, please try to cooperate them too. It's equally hard. I know you guys are working hard, but trust us, guys, we are also working more than double than our usual time. Trust us, guys. And probably you would not able to understand this thing, because I'm sorry to say, but you are not that mature to understand at our level. But please try to understand, please. We are putting our 100% right now. And we don't mind to do this thing, because ultimately whatever we have been doing, that is just for our student community, just for you guys. So I don't mind. Only thing is, my only expectation from you guys is just to follow me and get your good grades in this course. That's it. I don't have any other expectation. No. Because as we discussed very first day, that I'm worried about your parents. Being a parent, I know it's very difficult for us. Yep, it's hard. My son right now, he is in UC Berkeley. He is graduating this year. He already graduated, I would say. Yeah, so it's hard for us to manage money and all other resources, all other things. And equally, it would be harder for your, probably hard for your parents too. So that's the reason I'm working with you guys. Otherwise, we are supposed to check our emails just 2 or 3 or 4 times a day, but not every time, not every 1.5 hours or every after an hour. But we can do this thing just for you guys, so that we can communicate, we can try to help you out to solve your doubts. Right, guys? So please try to understand this thing. I know because of immaturity, sometimes you guys are getting upset too. I know that thing. And that is just the immature thing, because you don't know the other side of the mirror right now. You don't have that capacity to see this thing. It requires some time to get matured. Yeah, when the time will come, at that time you will realize this thing. I don't blame anybody. Please don't take it me other way, please. I'm not blaming anybody or any one of you. No, I'm just talking in general. So please try to understand this thing, guys, and try to follow me. If you have some doubt, yeah, politely you can ask us. But if you are being rude, nobody can help you out, right? Nobody likes the rudeness. So please be careful, guys. And if you have some doubt as far as concern of my subject, I don't mind. I will never say you know. Never, never. In my 22, 23 years of teaching experience, I have not disappointed my single student. Trust me. Lots of thousands of students I taught or they have passed through me. And yeah, whether I was in India or here, yeah. Anyway, so shall we continue with our syllabus? And Margie, I went through your exams too, and you did really good job, except few things, some small mistakes. But only thing is,
Okay, so you were able to see it correctly.
again, don't speak in between. Please try to develop this thing, please. Don't speak in between. Let somebody finish his views, and then after you will be asked to speak something, okay? Yeah, I went through your exam. You did a good job, except some small mistakes. Yeah. Only thing is, don't feel bad, but you are not well organized. If you feel bad, I don't mind. But if you can take this one positively, you can do really better in your life. Yeah. Just be little bit particular about your stuffs, how to organize the things, and that will help you too. Organization is not just not the submission of your assignments or test. Organization means how you manage your time, how you organize your time, how you organize your stuff, which things are given importance compared to other things. Shall I share you story with you guys, if you don't mind? If you mind, I can continue with my syllabus. I don't mind, but it's really important. Shall I share some? It's not the story; it's a fact. You want me to share with you?
Sure.
One of the US presidents, again, I will not disclose the name, that's not fair, but you can Google it. Yes. One of the US presidents, he was working hard extremely for the development of our country. You won't believe, but he used to work more than 18 hours a day. At the end of his first year, out of 4 years, tenure, first year, he came to know that people were not satisfied. Lots of issues were there. And he just asked to his secretary, that was going wrong. I've been working 18 hours a day. And even though people are not satisfied, people are not happy in our country, what's the reason? His secretary, he was really very smart guy. He said that, I can't say you, Mr. President, I can't say you anything. But please listen to me. Don't play with your cell phone, please. But I think you need to organize your time. Yes, trust me. Margie, I'm not using any sarcastic language, okay? Don't take me other way. I'm just talking in general, please. Don't take it personally. But yeah, that's what that said. You need to organize your matter, your time. And he said, how can I organize? How can I manage it? I've been working 18 hours. And that guy, the secretary, he said that, okay, let's do one thing. How many jobs, how many things you did in last 1 week? Will you please write it down in one piece of paper? And he wrote down 50 good events, what he did in last 1 week. And then he said that out of these 50, how many were really, really important for us? Really important, that means some of the things out of 50, probably 30 things, they were not that important. You can neglect, I'm saying, you can keep it pending. You can do that thing after some time. But you require to focus more on those 20 parts, 20 things. Did you do that thing? And that president, again, I will not disclose the name. President, he realized this thing. Oh my gosh. If I have put some more weightage on those 20 events on last week, probably I would have done a lot better than whatever the situation is current right now. Yes, guys. And then after he worked in that direction, he won't believe. Now, after that, he used to work, after that week, he used to work 14 or 15 hours a day, not 18. And he did a lot better than what he was in first year. So organization skill is the best skill. It's very best skill. Another incident. I did my PhD. I don't know whether you know this thing or not, but I did my PhD from India. That is second largest research institution in India. That is called Indian Institute of Science, Bangalore, IISc Bangalore, from where one of our presidents, Dr. Abdul Kalam, he did his PhD. That's fine. That's a different thing. After my PhD, my supervisor, he told me one thing. Yes, still I remember that thing after 20 years, 18 years. Tim, you did your PhD. Yeah, you're good with math. I don't have any doubt about you. Only thing is now you must know how to sell yourself. Listen to me, guys. You must know how to sell yourself. You have to have good organization skill. You have to have good vocabulary power. You have to have good convincing power. All these things are equally important in the life, guys. Trust me. Trust me. If your parents are really good, successful in their own field, ask them. If I am wrong, ask them. Or just share with them. That today our teacher or professor, he just discussed these type of things with us. Do you think that that was really important, or he was just passing the time? Yeah, you can say like this. I don't mind. That's fine. And try to get his feedback, her feedback. Yeah. If he is really successful in the life, just share with him. Up to certain level, knowledge is the base. It is required. But then after, main thing is how to manage the time. And that's why, girls, please take it easily. But yeah, I don't know about the girls, restroom, but in United States, in men's restroom, so many times at VMI, at least, you can find some posters, manage your time. Yep. So many times when I go to the restroom, at least 3-4 weeks are there in a year that somebody comes and try to stick some papers based on the management, time management. Yeah, the title was time management. Must know this thing, guys. And that's why so many guys, they are, okay, just Google, I forgot, Steve Jobs. Steve Jobs, like Apple CEO, you know it, right? And you might have heard about his life too. Just Google his life. How many hurdles he has passed through and how he overcome the situation. Time management, equally important, guys. We are here to just give you a lecture, that's fine. Just to teach you DFQ, that's fine. Anyone can teach you, probably. But no one can give you teaching with this type of things. These things are more important once you are done with your teaching. Teaching will give you the base. But then after, if you try to build a building on your base, all these skills, surrounding fields are required. Yeah, so many times I discuss this thing in the class when I'm in class with one-to-one contact with my students. Yeah, so many times, if sometimes they are not in a mood to learn some new things, that's fine. It's not required every time to learn the new things. No, it's okay. Once in a while, it's fine. We can talk something else. Yeah. We do meditation in the class. Yeah. You can ask all my students at VMI. Yeah. Those who do at least the courses with me before last semester. Yeah. We do meditation, 5-10 minutes. Yeah, I just spend in the time. Yeah. I teach them, or I would say I taught them techniques of meditation, how to do meditation, what are the advantages of meditation. Yeah. Nothing wrong in it. Nothing wrong. Even Dean knows this thing. VMI Dean, he knows this thing that I'm spending some time with the meditation, some other important things. That's fine. But he never told me anything. We are going to develop one meditation center at VMI too. Probably you don't know this thing, but yeah, probably in a nearer future, once this pandemic effect will be over, yeah, we are going to start something like that. And yeah, if you want to know about the benefits of meditation, I'm sorry guys, benefits of meditation, just Google it. So many universities, they have separate building for meditation, and people, they go over there and try to spend some time just for the mindfulness. You can write meditation, you can write mindfulness technique or benefits of mindfulness. Yep. So right now you are in that stage of life that you can touch the sky. Yes, you can do whatever you think. Think positively, work accordingly. Everyone is ready to work hard. But those who know how to manage the time and which events are given more importance, they are getting successful. Everyone is ready to work hard. Don't feel bad, but even donkeys are working hard. Yep. Right. So please, guys, be careful. This is just your first exam. You are not the loser. You are not the loser. Till the time to come, try to recover lots of things. Those who are below 70, don't worry. No. You have to have that passion. No, I can improve. I can do that thing. No, it's not that hard. If it is hard, I can contact my teacher. I will try to solve all my doubts. I will look at the videos and everything. I will put my 100%. And trust me, guys, once you put your 100%, and if you go to any of your teachers, because once you talk to your teacher, he has that experience that he will come to know this thing, whether you have gone through the stuffs or not. And once he come to know that, no, you are putting your efforts, definitely, very calmly, he will convince you. He will give his best. But if you just try to speak in the air, I'm sorry, guys, nobody would trust you. I hope probably you guys will agree with me, right? You won't find these type of things in probably any of the classes, at least on the post at VMI. Right? Who bothers about this thing? No. Everyone bothers about the teaching, the syllabus, to finish the syllabus. Teaching is not a big issue for me. As I told you, this is my 23rd year of teaching, so that's fine. I don't bother about it. If I want to finish a syllabus, I can finish the syllabus in just 7-8 days. That's fine. It's not a big deal for me. Or I can teach the same syllabus for 35 days. Yep. Some things are really, really important in the life. You can find these type of things from somebody's mouth only after the experience. Don't think that I'm telling all these things to you by reading some book or just some journal. No. I'm sharing all these things with you guys. That's my life's experience. When I was doing my PhD, I used to work at least 15 to 17 hours a day. Yes. Continuously for 5 years. You know what happened to me? One day, when I was doing my PhD, and I went to in the afternoon for lunch. It was a lunch time. I had my lunch. I came back to the university. And then after, again, I started learning the things. And immediately within 10-15 minutes, I just felt sleepy. Yep. And you won't believe, for next almost 1.5 to 2 hours, I didn't do anything. I was trying to pay attention on my my research work, my stuffs. I could not. So I just tried to figure it out that this eating part is bothering me. I just skipped my lunch for 5 years. I had some fruits, some light snacks like this. That's it. Some stimulator, tea, coffee, but not full lunch. No, I skipped it. Because that was bothering me. So you must know you are the best judge of your life. You are the best judge of yourself. When you throw the problem to other, when you is wrong at that time, your inner voice always says you this thing. Are you sure that that guy is wrong? Are you sure? Yeah, it's pinching you, but we didn't pay attention. We don't pay attention. If you pay attention, you will come to know, oh, no, I think I also did something wrong. I have not put my 100%. Yeah. Anyway, guys. So if you want to ignore this thing, that's fine. I don't mind. If you want to pay attention, whatever we discussed in this almost half an hour, it would be really great for you. Yeah. For me, it's same. All are same. Because that is my job. I don't think that my teaching job is just to finish the syllabus. No, my teaching job is to create the best citizens of the country. That's my job. That's what I believe. I don't want to know about others. No, that's not my job. I don't want to criticize anybody. No, that's not my job, not my nature. And I always extend my hands to help my friends, my students, my relatives, everyone. And I don't bother if somebody does wrong with me. That's fine. That's his or her karmas. strongly believe in theory of karmas. Yeah, again, Google it, theory of karmas. You will find lots of things. And it's tremendous. It's tremendous. I strongly believe in that. Strongly. Strongly means more than 100%. Yep. If you want to experience, if you want to, yes, sometimes I know I'm using little bit strict language, I would say, not the rough language, strict language. And you don't like this. I know this thing. I know. Don't think that I don't know. Trust me, guys, once upon a time, I was also a student, right? So I know student mentality, students community, how they think, how they behave. I know this thing. I passed through all these situations. So I know this thing. But again, guys, whatever I'm doing, that is for you guys. As per example, Marky, don't take it wrong. I forced her so many yesterday. I forced her to submit everything. Why? She submitted finally after some, I would say, communications. She sent to my email. I can look at the email. I can grade her exam. I graded her exam, honestly. Yeah. Marky, I graded your exam, but I did not put on canvas. I want you to be particular. That's what I want. And that's not for me. Again, I told you, I graded your exam. The number is there in my mind. It's there in my file. In my file, yes, it's there. But I did not disclose that thing because I just want you to be particular. That's what I want. And that will be helpful to you, not to me. Am I right? To any one of you. So please don't take me wrong, guys. If I am little strict, probably that is for your betterment. I told you very first day that if you guys will fail this course, I will not be the loser. If you are getting suppose A plus, I'm not going to gain anything. But it's a kind of satisfaction. Yeah. Last thing, let me share with you, and thereafter we'll continue with the syllabus. I had one student. Oh, 1 minute, guys. 1 minute. Let me. All of you are getting my what we say. All the videos and everything on YouTube.
Yes, sir.
Okay, guys. So please follow that thing.
Yes, sir.
The additional thing I'm doing for you guys, I'm not supposed to do this thing, but that's fine. If you guys are benefited, that sounds good to me. Okay, guys. So yeah, my previous recording was over. So I just saved my file because I have to upload. I don't have to, but I need to upload that video on YouTube for my other students too. Okay, guys. Can you see this? No, I did not share any files with you, right? Let me share the file with you and we can start the syllabus. I don't know, I was telling you something. Oh yeah, one of the students, he was from, Lafayette College, Pennsylvania. Is there any kind of college over there in Pennsylvania? I don't know, but she's near to Philadelphia. Yeah, and she took one summer course before a couple of years with me. Yeah, and it was just like the first summer. And you won't believe, as I told you that we started meditation in the class. So daily we meditate for 15 minutes or like this. Once the class was over, 9:15 to 9:30, that was just our meditation time. And you won't believe, but I really appreciate, she was extremely obedient student. Yeah, she came to me so many times and she said that I'm really poor in math. I didn't get more than C in any of my math courses since my 9th grade. Yeah, that's what she told me. And she failed Calc 2 for 3 times in her college. That's fine. And I said that I don't want your knowledge. That's fine. I just want your obedience and whatever, and your hard work. That's it. But she was extremely hard worker too. You won't believe, first test, almost she failed. I gave her another opportunity in retake. She was on C. Second test, she was on C. Third test, she got B. Fourth test, again she got B. And final, she ended up with B. And every day we were doing meditation. And every evening she used to spend half an hour for the meditation at home too. So morning in the class and evening, she used to spend half an hour. She was very conscious about that. She signed up for DFQ in the second summer with me. Yeah, I was teaching both the summers at the time in that particular year. And now because she was confident, because after 6-7 years of a gap, she got B grade in math course. Otherwise, she was below C. She was not more than C. And you won't believe, first test she got B, DFQ. Second test she got A. Third test she got A. Fourth test she got A. Final she ended up with A, highest rank in the class. Can you believe it? That is the benefit of meditation. And you won't believe, her dad, he met me, he came to see me. And he said, I don't know what you did with my daughter, but always he's talking about you. And she's doing meditation very regularly. Yeah. After 5-6 months, her dad, he came to me in my office. Yeah. So lots of benefits are there. And I'm really feeling good that somebody is getting something from me. That's good. If I'm helpful to somebody for his career, for his life, for his grades, it's really good. Anyway, so I think we talk a lot, almost 40 minutes. And now let me share my screen. Okay, guys, so look at here. Oops. Can you see my screen?
Yes, sir.
Yes, sir.
Okay. Practice test chapter 2 and 3 and oops. First example. M dx plus n dy equal to 0, exact differential equation. Second example, m dx plus n dy equal to 0, probably that sufficient condition would not be satisfied over here. So m dx and n dy, so you have to divide by m because this looks like a smaller function than the n. So 1 over m del n by del x minus del n by del y will be a function of y or x, and then go for the integrating factor and multiply that integrating factor with the given equation so that that condition would be satisfied and you can solve this one. Third example, m dx plus n dy equal to 0. Again, the same thing. M and n, m is smaller, divide by this one and you are going to get the function of y. Again, same thing, m dx plus n dy equal to 0. Again, for last 3 examples, probably you will not get the exactness. So you have to go for the integrating factor. Fourth example, x dy by dx plus y, x cube, y cube. If you divide by x throughout, here you're going to get x squared, here 1 over x. It's a non-linear differential equation. Y to the power 6 is a non-linearity. So divide by y to the power 6. So y to the power -5, that is your u. That is your u, non-linear function. Example number F. This can be converted in terms of the non-linear function dy by dx, or you can write m dx plus n dy equal to 0 also. So this is again the exact differential equation. Example G is non-linear dy by dx divided by xy square, divide by xy square throughout, and the initial condition. Dy by dt, t is your independent variable, so divide by t square first, and then take this term because power of y is 1 here. Try to pick each of my words, please. And then go back and plug this value here and take y square other side, and then solve this one. So this is the problem H, non-linear differential equation. And dy by dx, you know this thing. We did this example in our first test. 1 minus x minus y, take x minus common, so x plus y, and x plus y equal to u, and that's it. Okay, so now we are going to start the application of first order, first degree differential equation applications. A culture initially, Solomon Harris, read the problem. Culture initially has.
The culture initially has P number of bacteria.
P naught or P0, yeah.
P naught number of bacteria. At T equals 1H, number of bacteria is measured.
1H means T equal to 1 hour.
Okay. At T equals 1 to 1 hour, the number of bacteria is measured to be 3/2 P0.
T by 2 P0. That means it says that initially. Initially means, what does it mean? When T equal to 0, the culture is P0 number of bacteria. Now, after 1 hour, that means the bacteria is growing now. Right? The number of bacteria is, that is 3/2 than P0. Is 1.5 times more than P0. Go ahead. If the rate of growth, go ahead.
The rate of growth is proportional to the number of bacteria, P of T, present at time T.
Stop. Guys, whenever you are solving the application problems like this at that time, first of all, you have to figure it out from where you need to start your example. I would start this example from this one. Is the rate of growth. Rate of growth means rate of change of bacteria, right? Rate of growth means derivative is proportional. So proportionality constant. Proportional to the number of bacteria PT present time t. That means PT is the number of bacteria present at time t. So if I write capital PT equal to number of bacteria present at time t, rate of growth of bacteria means dP by dt. So dP by dt is proportional to dP. That is my differential equation. dP by dt, a differential equation will look like this one. dP by dt is proportional to P of T. Look at here. dP by dt, can you see here, guys? Yes or no?
Yes.
No, sir. Could you move it over just there? There we go.
Okay.
Oh.
Yes, I think you can see me, right? Yeah. Yes or no, guys? This one. Can you see my cursor?
Yes, sir.
Yeah, this part.
Is that P over Y, sir?
dP by dt proportional to P of T.
P of T. Okay.
Okay. So now I have proportionality constant, say dP by dt equal to some k times P. Shall I write like this? It is to be understood that P is a function of T. Yes or no, guys? I'm sorry. I'm sorry.
Yes, sir.
dP
That's
by
good.
dt equal to k times P. How can I solve this differential equation? Nina? How can I solve this differential equation?
The
Separate.
dP by dt equals kp.
Say again?
Which one are we looking at? Is it the bottom one, the dp?
By dt.
I'm unsure, sir.
No, I think you got it. Can you take the separable variable? Yes.
Yes, sir.
dP by P equal to K times dt. Shall I write like this? Nina, look at here.
Yes, sir.
Right? Now separable variable, take the integration. So I'm going to get ln of P equal to KT plus C1. Agree? So P equal to e to the power KT times e to the power C1. So P is a function of T and capital C e to the power KT. Look at here, look at the blocks. these, and these. Agree? Agree?
Yes, sir.
Yes, sir.
All of you? Nick,
Yes, sir.
Ilyas,
Yes, sir.
adjust,
Yes, sir.
Ilyas, adjust your video, please. Good. Okay, guys. So now plug the initial condition. What are the initial condition? P at 0 equal to small p0. Agree? And p at 1 over equal to 3 by 2 times p0. Look at my finger. These are the initial conditions. E at 0 equal to p suffix 0. P at 1 equal to 3 by 2 times p0. Agree? Plug these
Yes,
values.
sir.
Yeah, plug these values in your what? Plug these values in your differential equation and you will get the answer. Let's solve this example. Look at over here, guys. Now see, this is the practice test assignment. 15 examples are there. Do you remember I gave you this sheet for integration before we started our syllabus? I solved these examples. Look at over here. All the examples answers are here. Yep. 1, 2, 3, 4, 5, or it may be. All the answers are here. Now, I prepared one packet. If you have a printer, take the printout of this one. It will be helpful to you. My first example is whatever we are doing right now. A culture initially has P0 number of bacteria. Right? My second example is here. If you have a printout, you can just take the printout and you can write it down over here and you can complete the full packet. This completion of the full packet, that is the part of your syllabus, part of your homework. Either you can go for this one, I don't mind, because all the examples I took it from here, these examples, they are from this packet. Usually my experience is that students are afraid of applications of differential equations, and that's why, because lots of problems are there, varieties of problems are there, and that's why I just try to scrutinize some of the problems and created this packet for you guys, and I'm going to ask you from this packet in your exams. Yes. So, but you have to make sure that you have to go through all the examples without missing a single one. Third example, population growth. Whenever population growth problems are there, example 1, 2, 3, these are the problems of separable variable. Then after we will jump over offline population, again, the separable variable kind of example. Then after we are going to jump over the next article that is called the radioactive isotope. That is the, I would say this one is the kind of chemical reaction problem. Chemical reaction problem. So population growth, chemical reaction, and then after Newton's law of cooling and warming problem. Solomon Harris, where are you going? Newton's law of cooling and warming. Whenever the problem based on some cooling and warming like this, when the cake is removed from an oven, its temperature is measured something, after 3 minutes or 3 minutes later, the temperature is 200 degrees Fahrenheit. How long will it take the cake to come down, to cool down to the room temperature of 70 degrees Fahrenheit? See, it's a practical problem. At that time, we are going to use dt by dt equal to, can you see here, T is your dependent variable, right? This T is a dependent variable. Tm is a fixed, it's a surrounding temperature. K is a constant. Don't you think this is a kind of autonomous differential equation, whatever we did in last chapter? Autonomous differential equation, because just T is the dependent variable appears over here. There is no T over here, small t. Agree?
Yes, sir.
Right? So it's a Newton's law of cooling and warming problems. That is third type of problem. Then after, a thermometer is removed from again, Newton's law of cooling and warming. Small metal bar, Newton's law. Mixture of problems, chemical reaction problems. So example 9 and 10 and probably 11, 9, 10 and 11 based on chemical reaction problems. If one mixture is there in the tank and if you are going to add another mixture and what will be the output, all these things we can be identified using or can be solved using the chemical reaction problems. Okay, large tank, even example 12 is based on chemical reaction problem. 13, example 13 is electrical network circuit. 12-volt battery is connected to a series circuit in which the inductance is this one, blah, 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 resistance is this one, find determine the current if the initial current is 0. 14, 15, 16, based on electrical network circuit. So I consider all 5 types of applications for first order, first degree differential equations. Please try to take the printout of this one, try to read all these problems. And then after 17, one more too. Yeah, and then after, this is the end of the first packet. There are 2 packets. This is the second packet. Population dynamics. Right now, pandemic is going on. Pandemic effect is going on throughout the world. Suppose somebody is affected by this coronavirus and he comes to the campus. Guys, look at me. He comes to the campus. Initially, only that guy is affected. All other guys were good. But in next 5 days, suppose 50 guys are affected. 50 guys are affected. So we have 2 conditions. One is initially just 1 guy. So when time t equal to 0, it is 1. When time t equal to 5 days, 50 guys are affected. What? Yes. What would be the situation? What would be the situation if situation after 12 days? How many people will be affected for 12 days? These type of problems can be answered using the population dynamics problem. I have considered one problem over here. This is the problem. This is almost similar to whatever the situation is right now, whatever is going on right now. Ilyas, please read this problem.
Here we go. Logistics growth. Suppose a student carrying a flu virus returns to an isolated college campus of 1,000 students. If it is assumed that the rate at which the virus spreads is proportional not only to number X of infected students, but also to a number of students not infected, determine the number of infected students after 6 days if it is further observed that after 4 days, X of 4 equals 50.
Right, guys? Exactly same as pandemic. Suppose 1 guy is affected and suppose after that 50 guys are affected in next 5 days, then these 50 guys, they will be in touch with some other guys and the disease will be spreaded like anything throughout the campus. So how many guys will be affected approximately after 12 days? This type of questions can be answered using the differential equations. That's another application of differential equations. The 6th part question. Ilyas, you raise your hand, right?
Yes, sir. Dr. Dimple, it says, it is assumed that the rate at which the virus spreads is proportional not only to number X of infected students, but also to the number of students not infected. What does that mean?
Suppose, how many students are there? 1,000.
1,000.
Right? Number of affected students is X. Suppose number of affected students are X. How many students are not affected?
Oh, 1,000
minus X. Right?
Right.
That means suppose it is assumed, suppose you are writing your equation dx by dt because X is the number of infected students. So dx by dt is equal to X times 1,000 minus X. That's what your differential equation would be. Make sense? And that is of the type that non-autonomous differential equation.
Yes, sir.
Right? We will take care of all these things. Don't worry. Right now, I'm just giving you the brief idea about this chapter. And I want to finish this chapter by tomorrow. And immediately, I'm sorry guys, but you are taking your next exam on Friday. Be ready with that on Friday. Today is Wednesday, right? I know you took your test, and that's the reason I wanted you to take your test on last Friday, but that's fine. That's fine. But this time, yes, you are taking your next exam on Friday, and then after every Friday will be your exam. Every Friday. This chapter is not that lengthy. Just few examples. Please work hard, guys. Okay. Yes. Same type of example. Then another is radioactive series examples. Sixth type of differential equation. And finally, network problem. So that the system of differential equations that describes the current I2 and I1 in the electrical network system is given in this form. And this is some figure is provided to you. I will let you know how to solve, how to get this type of things. Electrical network system. It's not now RT-RL circuit, it is capacitor C is there. I will let you know what is the difference. One more example, probably two more. Yep. And that is the end of this chapter. That is the end of the chapter. Right, guys? I would appreciate you guys, if possible, I would say that please open your canvas and try to open this chapter and try to start with that. Try to open that assignment, question number 1, whatever Harris read the question, the first one.
Yes, sir. I think it's on page 31.
Page 31, right?
I think so.
Now, what it may be, just open the canvas. I just want you to open this one. See, look at over here. I want you to open this one. This packet, article chapter 3.1, this one. Bacteria growth problem. Throughout this chapter, today and tomorrow, please try to open this part. Okay, and one by one, not all, almost all, 80% I will be solving here. Similar kind of things you can do it by your own. We just already discussed about the nonlinear and the exact differential equation. So please go through that part too. Okay, good. So let me start with this first example. Don't look at my screen. Please don't look at my screen. I will let you know when you are supposed to look at over here. But right now, I would say that open this one on your canvas, side to your screen, and read this problem, because you will not find the problems whenever I will be providing you the solutions. At that time, we require these lines, this example. Okay, guys. I hope all you guys have opened your canvas, right? Yes or no? Yes or no?
Yes, sir.
Okay. So your
Yes,
first
sir.
problem. As I told you, PT be the number of bacteria at time t. So dP by dt equal to PT. Agree? That's what I wrote it down. So proportionality constant is K. Then after I can take this, I can divide by P, and dt is the other side. That means separable variable. Once you separate the variable, I can go for the integrations. ln P equal to KT plus C1. So PT equal to e to the power KT plus C1. Plus sign is there, so e to the power KT times e to the power C1. E is constant, C1 is constant, e to the power C1 is constant, so whole part is constant. Let me put some capital C times e to the power KT. That means my differential equation solution is PT equal to C times e to the power KT. This is the first order, first degree differential equation separable variable. My initial condition when time t equal to 0, number of bacteria in the culture was P0. So replace this T by 0. T by 0, so here it is, e to the power 0 is 1, so C equal to P0. Go back and plug this value of C over here, so we are getting this one, PT equal to P0 e to the power KT. My second condition was, after 1 hour, 3 by 2 times bacteria were there, right? 1.5 times. So if I replace this T by 1, so P1 is 3 by 2 P0, P0 as it is, e to the power k, t is 1. Now you can see over here, this condition will allow me to take the value of this constant k. First of all, I found the value of the constant of integration c. Now I am getting the value of the constant of what? Proportionality constant value k. Again, I am on my words that your initial values will provide us the values of the constant in the given equation. Here we have two equations, two constants, and that's why we have two initial conditions. So if you take P1, if you replace this t by 1, you're going to get 3 by 2 P0 equal to P0. P0 will get cancelled out in e to the power k. If I want to remove this e, I have to take the ln function both the sides. So ln of 3 by 2 equal to ln of e to the power k. Ln and exponential functions will cancel out and you're going to get k. So k equal to ln of 3 by 2. Use your calculator. You're going to get k equal to 4055.4055. Go back and plug this value of k over here. So you're getting pt equal to p0 e to the power 0.4055 times t. That is now my particular solution. It says that how many bacteria would be there, right? Or at what time the culture would be having 3 times the initial number of bacteria. That was the question. Am I right? Look at the last line of the question, please. Nick, read the last line of the question. Nick.
Sorry, sir. I'm just switching back to it. I had Zoom up over it. If the rate of growth is proportional to the number of bacteria, P of t, present at time t, determine the time necessary for the number of bacteria to triple.
Right? Determine the time with the number of bacteria that is 3 times than the initial number of bacteria, right? So that means we are looking for P at what time is equal to 3 times P0. Look at here, is equal to 3 times P0. P at what time is equal to 3 times P0. So 3 times P0, just replace this one. 3 times P0, P0 is here, e to the power this one and t. So you can find your t. P0 will get cancelled out, right? And then take 3 times P0, so 3 is left out over here. Take ln of 3 equal to ln of this one. So ln of 3 is one value. Use your calculator, divide by this 0.4050 and you are getting t. So t equal to this number of years, or sorry, hours, not years, hours, the number of bacteria would be triple than the total number of bacteria in your culture. Sounds good? Yes or no?
Yes, sir.
Ilyas, I like your reading style. Really good. Yeah. Very clear, very slowly, little loudly. I like your style. Good.
Thank you, sir.
Yeah. Then Gage Levine, would you like to read the second example from the practice test?
Yes, sir.
Go ahead.
A culture initially has a P0 number of bacteria at T equal to 1H. The number of bacteria is measured to be 3/2 PO if the rate of growth is proportional to the number of bacteria, PT, present at the time T, determine the time necessary for the number of bacteria to triple.
This is the example what we did. I want you to read the next example. This is the example just now we did and answer is in front of you. I just want you to read the next example. Gage. Right?
Yes, sir.
Go ahead.
The population of a community is known to increase.
Slowly. Again, stop, start.
The population of a community is known to increase at a rate proportional to the number of people present at at time t. The initial population PL has doubled in 5 years. How long will it take to triple to quadruple?
I'm sorry, but I could not hear you properly. Queen Heart, would you read the same example for me?
Let me get pulled up real quick.
Please
The
keep that one in front of you. Keep it
The
in yourself.
population,
Yeah, sorry.
the population of a community is known to increase at a rate proportional to the number of people present at time t. If an initial population P naught has doubled in 5 years, how long will it take to triple or to quadruple?
Right, guys? So at time t equal to 0, it is P0. After 5, whatever it may be, suppose P at 5 equal to 3 times P0. These two conditions you can use to get your value of C and K, your constant of integration and the proportionality constant. And then after you are going to get some particular solution. And then after whatever the equation is asked, whatever the question is asked to you, follow that question and try to get your answer. Try to find the value of K and value of T or what it may be. This example is exactly parallel to the first one. Agree? Agree?
Yes, sir.
Yes, sir.
Okay, so the second example, that is homework. Second example is homework. Right? Question number 3. Question number 3 is slightly different. Question number 3. Who wants to read question number 3? Margie, you want to read? If no, then fine.
Oh, sorry, I was muted. The population of a town grows at a rate proportional to the population present at time t. The initial population of 500 increases by 15% in 10 years. What will the population be in 30 years? How fast is the population growing at t equals 30?
Right. So there are 3 questions. The population PT with the population at time t. So again, your first stage will remain the same. But the only thing is your initial condition is given in terms of the percentage. So just be little careful. Otherwise, the things are exactly parallel to the first 2 examples. So dP is proportional to PdP by P, KdT, lnP, C to the power KT. Things are same here. Only thing is it says that initially P is equal to 500. And then after 15% of the initial population, 15% of 500 is 75. Agree? Yes or no?
Yes, sir.
Right? 15 plus 15, 5 is 75, 75. So total population, 15% of the population is increased, right? So 500 was the initial population, 75, that is the increment. So total population would be 575 after 10 years. So P at 10 equal to 575. And P at 30, how much? That's what we need to figure it out. So P at 10 equal to 575. That will give you the value of K. Go back and plug the value of K. And then after, what was the question? The question is at 30 years. Okay. When T equal to 30 years, what will happen? 760 persons, right? The total population will be 760 after 30 years. Simple. Question number 4, little bit more careful. Question number 1 to 3, they are just similar. Question number 4, actually I wanted to mean this one about the initial condition. 1, 2, 3, they are just same. Nina, would you please read this one? Question number 4 from your practice test slowly.
Yes, sir.
Slowly. Go ahead.
Are you there, sir?
Yes.
Sorry, I didn't know if you could hear me.
I can hear you.
Question number 4. It says, not the radioactive series. I don't know.
Offline
Sorry.
population.
Sorry, when I switch back and forth from my screens, it gets, okay. Half-line of population, a breeder reactor converts relatively stable uranium-238 into the isotope plutonium-239 After 15 years, it is determined that 0.043% of the initial amount of A sub 0 of plutonium has disintegrated.
Disintegrated, right? So it says disintegrated, right? So what should be your AT? AT be the amount of plutonium remaining at time t, means non-disintegrated. So amount of plutonium remaining at time t, non-disintegrated. That's what you need to figure it out, guys. This is the most important thing. Go ahead.
Find the half-life of this isotope if the rate of the disintegration is proportional to the amount remaining.
Right, rate of disintegration means dA by dt with respect to time. That is amount of plutonium disintegrated. So dA by dt is proportional to AT. See, your last line gives you the differential equation formation. So dA by A equal to k dt, then the things are same. So ln of A equal to kt plus c1, AT equal to e to the power kt plus c1, kt plus c1 of course, and this e to the power kt plus c1, e to the power kt times e to the power c1, e to the power c1 is constant c. So c e to the power kt. Initially, the amount of non-disintegrated at time t equal to 0 is A0. So if you plug that time t equal to 0, if you plug it over here, so ln of A equal to kt plus c1. So AT equal to this one, okay. So time t equal to 0, this is A0. C e to the power 0 is 1. So C equal to A0, go back and plug it over here. AT equal to A0 e to the power kt now. This is my new equation. My second condition, 15% of the plutonium non-disintegrated, right? It says A0 equal to A0, 15%. Now amount of plutonium disintegrated is given like this. So here it is, suppose 1.0000. So total is 1. Then what it says, 0.00043 amount of plutonium non-disintegrated. This is given to you. Am I right, guys? So if you take this 0.00043, so if you subtract this one from 1, you are going to get the amount of plutonium non-disintegrated. That means after 15 years, this much of amount, this is the amount of plutonium disintegrated. But we are looking for the non-disintegrated. That means we have to subtract from 1. So 1 minus this one, that is the amount of plutonium non-disintegrated. I told you this is a little bit tricky about your, I would say, for your initial condition. So after 15 years, because you are given the amount of plutonium integrated and you are looking for, disintegrated, and you are looking for the amount of plutonium non-disintegrated. So after 15 years, this much of amount of plutonium, and don't forget this is A0, please, initial condition, initial plutonium of non-disintegrated. So this much of A0 will be the non-disintegrated amount of plutonium. So this is my second initial condition. If I use that second initial condition over here by taking P equal to 15, so this is my left-hand side, A0 e to the power K as it is, and T equal to 15, T equal to 15. A0 will get cancelled out. I want to remove this T, E. That means I have to take ln both sides. So ln of this one equal to 15K. Look at here, this and this equation. If I divide by 15, I'm going to get the value of K. You are getting value of K negative. That's fine. Don't worry about it. Just go back and plug this value of K in your last solution here. Plug it over here on K. So AT equal to A0 e to the power this one, and this is, don't forget, this is your T. Last part is T. Now, your problem says that the half-line means the value of time at which AT equal to 1 by 2. Half-line disintegrated means the value of time AT equal to one half of A0. So whatever you are getting over here, this is actually, I have to put one block over here. That's fine. So AT equal to 1 by 2 times A0, half-life of plutonium. Half-life. So 1 by 2 A0, A0 as it is, e to the power negative this one as it is, and times T. So I can find now T. This A0 will get cancelled out, and ln of 2, you can write 2 inverse. You can use the property of logarithmic function, ln of A to the power B, that is B times ln of A, like this. So take this one over here as a coefficient. So this negative and this negative will get cancelled out, and you are going to get ln2 divided by this one equal to t, and that makes sense because t is time. It should not be negative. It cannot be negative. So t equal to 24,176 years. After this much of long time period, the amount of plutonium would be disintegrated, right? Half-line amount of plutonium will be disintegrated. So that's what we mean by the separable variable, or I would say the population growth or chemical reaction problem. Chemical reaction problems are divided into two parts. One is separable variable, just now we saw here. Another part is chemical reaction that is in tank. Suppose one tank is there and we mix. That is a mixture of problem actually. It's not chemical reaction. Chemical reaction is this one. And mixture of chemicals, that would be the separate type of differential equation. Mixture of chemicals. Okay guys, then after in the packet, I told you that we have Newton's law of cooling and warming. Always keep in mind this thing. Again, see, you will not find these type of things in the book, but always Newton's law of cooling and warming would be converted to separable variable. Separable variable. So Newton's law of cooling and warming, separable variable, dt by dt, always we are using this one. When you find any example based on Newton's law of cooling and warming, at that time, blindly use this equation, dt by dt equal to k times t minus tm. What this number says, what these numbers say, this k is the proportionality constant because actually rate of change of temperature T with respect to time is proportional to T minus Tm. Temperature of the object minus the surrounding temperature of the medium. Surrounding medium temperature of the object, you can say. And this is always fixed. This Tm is fixed. Tm is not a variable, so it is some number. So please keep in mind this thing because that's a fixed temperature, right? Like room temperature, something like that. It's a fixed temperature. Hello? Sorry, guys. So, Tm equal to 70 like this, right? Now I want you to read the example number 6. Example 5 is homework, is just like the previous example. That's fine. Example 6, read the problem. Who wants to read this one? Paul Mustian. Paul Mustian. I want you to read this problem. Example number 6 from the packet.
When a cake is removed from an oven, its temperature is measured at 300 degrees Fahrenheit. 3 minutes later, its temperature is 200 degrees Fahrenheit. How long will it take for the cake to cool off at room temperature 70 degrees Fahrenheit?
Right. Now room temperature is 70 degrees Fahrenheit. Is there any way that you can change this room temperature? No. That's not in your hand, right? You cannot change the room temperature. Right, guys? Atmospheric temperature, you cannot change it. So that is considered as my Tm. So here my Tm equal to 70. So let me just plug my 70 over here. dt by dt equal to k times t minus 70. Right? Alex, which type of differential equation is this? My cursor.
This would be a non-linear.
Non-linear? Are you sure?
No.
Do you find any small t over here? Or any, no?
Oh, no.
Sir, wouldn't that be separable?
Oh, Queen Heart, who said this thing?
As well. Hosteller.
Hosteller, okay, yeah, he's right. It's a separable variable, t minus 7. See, if you divide by t minus 70, dt of 70 equal to kdt. See here, variables are separated. One is capital T, one side it is small t. Go for the integration. Ln of t minus 70 equal to this one, e to the power kt and e to the power, this is my constant c. So tt equal to 70 plus c to the power kt. Initially, the temperature is 300 degrees Fahrenheit. Am I right? Almost 10?
Yes, sir.
Hostetler, are you getting me?
Yes, sir.
Yeah, so if you replace this small t by 0, e to the power 0 by 1, t is 0 equal to 300. 300 minus 70 equal to c. So 300 minus 70 is 270. So 230. So c equal to 230. Just go back and plug it over here. So my tt equal to 70 plus 230 e to the power kt. That is my new equation. I would like to use my second initial condition by replacing this T by 3, so that 200 degree Fahrenheit, that is my temperature, right, of the oven, and 70 as it is 230 e to the power K. And because you know, once the highest temperature was 300, and then after you stop the oven, that means temperature reduces. And that's why after 3 minutes, the temperature cools down from 300 to 200 degree Fahrenheit. Right, guys? That's what the meaning. That's what you know, right? If you keep something in the oven, and suppose the oven goes to 350 degree Fahrenheit, and suppose that item is cooked, then after you can switch off your oven and temperature goes down rapidly. Agree, guys? But it will take some time for that item cake to cool down to the room temperature, because initial temperature gets down very rapidly, but then after it takes some time to come to the room temperature. And that's what exactly happening over here too. So after 3 minutes, the temperature of the oven is 200 degree Fahrenheit. So use this one to try to get the value of this proportionality constant K. And that's what I did just like our previous technique. So K equal to negative 0.190. Go back and plug it over here. Go back and plug it over here. Once you plug it over here, you're going to get, this is my equation. T of t equal to 70 plus 230. 70, just look at over here. 70 plus 230 e to the power this one. The question is, at what time your temperature will be 70 degree Fahrenheit? This question is really, it's a valid question, but the answer is tricky. Why? Because I want my temperature of my cake 70 degree Fahrenheit. That means I want this circle part, I want this part 0. Which value of t will make this part 0? Because actually this 230 e to the power negative 0.190 t can be visualized as 230 divided by e to the power 0.190 t. Agree? In division, if I take, suppose t tends to infinity, time goes to infinity. So e to the power infinity is infinity. 230 over infinity is 0. Any number divided by infinity is 0. That means this part will disappear. This part will vanish. Am I right? That is possible only if I take t tends to infinity. But is it possible physically that I can go for t tends to infinity? Yes
No,
or
sir.
No? Or other way around, I would say that what is the physical interpretation related to this problem for t tends to infinity? Any explanation, any one of you out of these 12 guys? Oh my gosh. Yeah. So I took t tends to infinity. Look at over here, t tends to infinity of t. So this is 30 divided by e to the power t, and t is infinity. 230 divided by infinity, that is 0. So 70. I'm getting my answer by taking t tends to infinity. But what does it mean? This t tends to infinity means, guys, look at over here. Cake is getting down, I'm going to say cooling down to room temperature, 70 degree Fahrenheit, right? Are you getting me, guys?
Right.
It is extremely difficult to figure it out when cake is going to attain the room temperature. Because some of the portion of the cake, look at over here, suppose the upper portion of the cake will be cooling down comparatively faster than the inner portion of the cake. So upper portion, that will come to the room temperature, but not the inner portion. It will take some time, maybe some microseconds, some seconds, some few more seconds. We don't know. Another thing is, Suppose you are measuring this thing, that temperature is going down. It is suppose 3 minutes, 5 seconds, 3 minutes, 33 seconds, 3 minutes. 3 minutes, 33 seconds, 3 minutes, 50 seconds, 3 minutes, 52 seconds. And as soon as you measure it, it will become 3 minutes, 35 seconds and 30 milliseconds. You don't know. You are ignoring those parts, which are irrational numbers, kind of irrational numbers, which are not bounded. Because of that reason, this t tends to infinity here in this case relates with that uncertain numbers, uncertain time in microseconds that relates with this one. And that's why we are writing t tends. Here t tends to infinity doesn't mean that you can keep this cake 100 hours, 200 hours, 500 hours, 1000 hours to cool down the room temperature. You know, if you keep the cake for 100 hours or 1000 hours, it will not be in a position to eat, right? So it's of no use. Am I right, guys? So this tends to infinity doesn't mean over here that you are thinking about a long period of time. No, you are not thinking in that direction, but you are thinking in this direction, whatever I explained to you. Any doubt? Any doubt?
No, sir.
Sure. So is it infinite just because it goes asymptotic at that 70-degree mark, so it never actually like
Who is
touches
there?
it?
I can't see that guy. Who is there?
It's Hostetler again.
Okay.
So it just kind of goes off into infinity and never actually touches 70, theoretically, just on paper.
It will theoretically, it will touch 70, but other way around, see, it's a wrong thinking. It will touch 70 degrees Fahrenheit because if you keep any of the things, any item in the room temperature, it will come down to that temperature. Thing is, for time, the time is exactly not whatever you are going to measure. Suppose, as I told you, that suppose after 5 minutes, 30 seconds and 20 milliseconds, if you try to hit that, it touches 70, but at that time, your second will be different. Are you getting me? Suppose you are getting 5 minutes, 20 seconds, and if you say 5:20 and let me click this one, it will be 21. It will be 19. You never know. It will be somewhere in between. And somewhere in between, that means we mean that t tends to infinity because all are those all are the irrational numbers which goes to infinity. And between two rationals and two irrationals, there are infinitely many rationals and irrational numbers, respectively. That is called Dedekind cuts in mathematics language. So that's why we are taking infinity. Make sense?
Yes, sir.
Okay. Any other doubt, guys? Chemical reaction problem. Chemical reaction problem. You want me to start this problem, or if you want, we can continue this problem tomorrow. What do you want? Or if you want, I can continue with this one. It's up to you.
We could finish on this one.
Sure? All you guys?
Yeah.
All you guys agree with Alex?
Yeah, I
Yes, sir.
agree.
Yes, sir.
Yeah.
Good. Let's go for this one. Nice of you guys. Okay, chemical reaction, another type of problem. Now look at over here. I solved this Newton's law of cooling and heating problem, and other two examples I gave to you in the packet. They are exactly similar. Just go ahead and solve that one, number 7 and 8. Now chemical reaction problem. Please keep in mind this thing. Whenever you are working with chemical reaction problem, I think it's better if I discuss this thing here. Okay. I have one tank. The brain R in 3 gallons per minute is over there in the tank. Water is already there in the tank. The mixture is coming out at the rate of 3 gallons per minute. It's pumped in at the rate of 3 gallons per minute. Same rate, it's coming in and coming out. It should not be same every time, please. But in this example, it is same. So whenever you have this tank type of problem, chemical mixture problem, not chemical reaction, chemical mixture problem, always think about this one, R in minus R out. Question is, what is my R in? What is my R out? R in and R out. Now I want, who is left out? Who wants to read this problem? Question 9, any one of you? Take the initiative, guys. Take the initiative. Nathan Light. Nathan Light.
You want me to read the problem?
Question number 9 for me slowly.
Let me pull it up. I was down with you.
I'm tired.
Question 9.
Question 9.
A 30-volt
What? No. Packet 1.
Packet 1?
Yes.
Honestly, what are you talking about? A mixture of two solutions. That one?
You don't know chemical reaction problem. Question 9.
dA over dt. A large tank held 300 gallons
Correct.
of a brine solution.
Correct.
Salt was entering and leaving the tank. A brine solution was being pumped into the tank at a rate of 3 gallons per minute. It mixed with the solution there, and then the mixture was pumped out at a rate of 3 gallons per minute. The concentration of the salt in the inflow or solution entering was 2 pounds per gallon. So salt was entering the tank at a rate Rn equals 2 pounds per gallon times 3 gallons per minute equals 6 pounds per minute. And leaving the tank at the rate R out equals A over 300 pounds per gallon times 3 gallons per minute equals A over 100 pounds per minute. If 50 pounds of salt was dissolved initially in the 300 gallons, how much salt is in the tank after a long time?
Okay, I want Ilyas to read this problem slowly.
Yes, sir. The same one, sir?
Same one.
Okay. A large tank held 300 gallons of a brine solution.
Wait, 300 gallons of brine solution that is over here. Look at here. Always draw the picture whenever you are working with chemical mixture. Next.
Salt was entering and leaving the tank.
Salt is entering and leaving the tank at the rate of 3 gallons per minute. Agree?
A brine solution was being pumped into the tank at a rate of 3 gallons a minute.
And salt is entering at the rate of 2 gallons per minute, right?
It mixed with the solution there, and then the mixture was pumped out at the rate of 3 gallons a minute. The concentration of the salt in the inflow or solution entering was 2 pounds per gallon.
Okay, so say again.
The concentration of the salt
of the solution
in the inflow or solution entering was 2 pounds
the solution entering 2 pounds. So whenever you are going to fix your Rin at that time, whatever Rin, the brine solution rate was given to you 3 gallons per minute, and this salt concentration is given to you 2 lb per gallon. Multiply these two always. Always multiply these two to fix your Rin. So 2 lb per gallon, write your unit also, and 3 gallon per lb. This gallon will get cancelled out, and 2 lb per minute is the answer. So Rin equal to 6 lb per minute, right? 80 is the actually you need to write this one first. I'm sorry. You need to write this thing over here before you start this equation. 80 is the amount of salt at time t. That 80 be the amount of salt at time t in the brine solution. R out equal to 80 is the amount of salt at time t, right? After time t, what will happen? 80, we don't know. 80 is the amount of salt at time t. Brine solution coming out at the rate of 3 gallons per minute. So again, now you are taking the multiplication of this 3 gallons per minute, 3 gallons per minute with this 80 amount of salt coming out after time t from here. So A by 300. Why by 300? Because 300 gallon of brine was there inside the tank. So divide your A always by the number of gallons over here in the tank. So A by 300 LB per gallon. Don't forget your units, guys, please. A by 300 LB per gallon and 3 gallon per minute. Gallon will get cancelled out and A LB per minute. A by 300 LB per minute. Plug this values of R in and R out in the equation. R in, this 3 and 3 also will get cancelled out. So you're going to get A by 100 LB per minute. Okay. So if you plug this one, R in and R out, you're going to get dA by dt equal to 6 minus A by 100. Now you don't, once you fix it R in, R out, box it, then you don't want these units. R in, R out. Initially, gram of salt was there, A0 equal to 50 gram, right? Initial condition is provided to you. If I take this one, this A other side, I'm going to get dA by dt equal to 1 over 100 A equal to 6. Which type of differential equation is this?
Linear, sir.
Linear, right? dy by dx plus py equal to linear differential equation. Always, guys, keep in mind this thing whenever you are working with chemical mixture problems, like tank problem, always it will give you the linear differential equation. Always. So this is the application of linear differential equation. So dA, and this is my dy by dx plus py equal to q. My p is constant over here. Q is constant. Integrating factor it is power p dx. And general solution formula. So integrating factor 1 over 100 dt e to the power t over 100, because 1 over 100 is out and integration of 1 is t. So t over 100. General solution, y dependent here, a is dependent. So dependent variable a e to the integrating factor equal to right hand side 6 q multiplied by integrating factor dt plus c. E to the power t by 100 equal to 6 e to the power t by 100 integration is t by 100 equal to u. So you can divide by 1 by 100. You are going to get this if you use u sub plus c. If you divide throughout by e to the power t by 100, so this will get cancelled out. This will get cancelled out. This 100 will be over here, or 600 and c e to the power negative t by 100, because you are dividing throughout by these, so it will be over here, negative. Initially at 0 equal to 50, so when time t equal to 0, 50, write down 50 over here. So 50 here is equal to 600 plus c e to the power 0 means 1. So c equal to negative 550. Go back and plug it over here. So that is this one. At time t tends to infinity, what will happen? At equal to 600 lb. And that is your answer. This example is again like the previous example, Newton's law of heating and cooling, right? When you are going to get the 600 lb, that was the question. So if you take the time t tends to infinity, you're going to get this one. Time t tends to infinity. Any question in this one?
Yes, sir.
Okay, example number 10. Who wants to read this one? Example 10. Somebody? Nick? Or Ismail? Ismail, let me give him this chance. Ismail. We can't hear you, guy. What he said? Ismail.
A tank contains 200 liters of fluid in which 30 grams of salt is dissolved. Brine containing 1 gram of salt per liter is then pumped into the tank at a rate of 4 liters per minute.
Wait, brine contains 1 gram per liter and brine contains 4 liters per minute, right? So I just multiplied this one, I'm going to get 4 gram per minute. 1 gram per liter and 4 gram per liter per minute. So this is my R in. AT be the amount of salt at time t, just like previous example. Inside it is 200 liters. So A divided by 200 gram per liter. And R out is also given to you. Am I right, Ilyas, Ismail? Out is 4 liters per minute. So 4 liters per minute. Cancel this liter and liter. So A by 200 gram per minute. This is 4. So A by 50 actually gram per are out. Plug the values, linear differential equation, integrating factor, general solution. My answer will be this one. Initial condition A at 0 equal to 30, right? Ismail? A 30.
Yes.
Okay, so that means my C equal to negative 170. You go back and plug it over here. And that's the answer. Question number 11 and 12, we will see tomorrow. Okay, it's an electrical network. Work hard, guys. You have just 2 days. You are taking your exam day after tomorrow. So please work hard. I know. And you know why I'm doing this thing? Because of Ismail. Because Ismail, he is taking Calc 2 and DFQ right now in this first summer. So I don't want him to mess up both the exams. I just want him to take one exam on Friday and second exam on Monday or Tuesday, whatever it may be. Right? And another thing is I always want my exam on Friday. Yeah, so that I can have some more time to grade your exams. Yesterday it was horrible for me. You won't believe, but I really worked hard yesterday. Yeah, I went to VMI yesterday morning at 8:30. Yeah, I reached over there at 8:30, and then after I left at 7 p.m., I came back home at 8 p.m.
Dr. Dimple?
Yes, sir.
Exact differential equations will be on the exam as well.
Who is there?
Oh, this is Elias.
Elias, okay. Go
So
ahead.
exact differential equations from the last chapter, that will also be part of this exam, correct?
Yes, exact
Okay.
differential equation and non-linear both will be the part of the next exam. Okay.
So the homework is just the packets, those 2 packets?
Homework is the packet, and the first one I gave it to you. That is also the homework and example number 11 of the previous test.
All right.
That is exact differential equation. So please work on that. This time I'm not going to provide you any extra time, guys. So if you don't know how to submit your assignment, you guys discuss in between. If somebody wants to help you out or discuss this thing, that's fine. Go ahead right now. And if you think that you are good, I don't mind. I'm going to open your Canvas. Those who have not submitted their exam on Canvas or homework on Canvas, I'm going to open that one on Canvas for a couple more hours today. Okay, probably it would be up to 2 p.m., not more than 2 p.m. So please fix that one. You want to discuss this thing in between? I am out of picture now. If you want to discuss in this thing in between, I don't mind. Just go ahead. If somebody wants to help you out or somebody wants to ask you, ask somebody. No? Okay, your choice. Okay, if you guys are good, that's fine. I don't mind. Okay, guys, thank you so much. And I will see you tomorrow. Sounds good?
All right.
Sounds good. Have a good day,
Have
sir.
a good day, sir.
Have a good day, sir.
So, thank you, guys. Yep. Take care.
Just on my exam grade, or are you gonna wait to put that on?
Say again.
My exam grade.
Again, just submit that one. I will add that one very immediately. Okay.
Okay, all right, thank you.
You got, everyone is out? Yeah.
Yeah.
Got 88%. Yeah. You got 88. 30 of 40. Okay.
Okay, thank you.
You are doing good, but only thing is just follow me. Okay.
Okay, all right, thank you very much, sir.
No problem. And yesterday you were not in our roster, so I worked for 1 hour.
I wasn't sure because I come
No,
up.
that's not your part. That was the management part. Something went wrong in administration office.
So do you still want me to submit it onto Canvas so it's there?
Yes, please.
Okay, thank you.
No problem.